All right, guys, we're looking at right triangle trigonometry activity. So we need a ruler and protractor for this. Okay, so if you don't, you're going to have to borrow so that we have enough. We're going to draw a right triangle with an acute angle of 40 degrees. Then we're going to label the leg adjacent to 40 degrees, adjacent, the leg opposite 40 degrees, opposite, and then we're going to label the hypotenuse height for hypotenuse. Measure the three sides of the triangle to the nearest centimeters, and label the sides with their lengths. Find the ratios of adjacent over hypotenuse, opposite over adjacent for your triangle, and round to the nearest hundredth, 2 decimal places. Compare your answers to problem number 3 with the rest of your group. Everybody's in a table with people. That's your group, those 4 people. You may not move your seats today. This is it. Okay. So, I'm going to start going over number 1 a little bit just to get you guys started, and then I'm going to let you work on your own. So, the first thing I'm going to do is I'm going to make an angle, a triangle, where one of the angles is 40 degrees. So I take my protractor. I'm going to label this 1. This is problems 1 through 4. Okay? I'm going to draw a straight line. And then I'm going to pick one side. I'm going to put the hole in my protractor at the very end of my segment, and I'm going to put a mark at 40 degrees. Okay? Then I'm going to connect that line. Shh. And then I'm going to draw straight down. So this is now 40 degrees, and this is now 90. Everybody should be doing this right now. You can do this in your notebook. You can do this on a piece of notebook paper that I told you to pick up, but everybody should be doing this right now. Now, everybody's triangle is going to be a different size. Okay? Everyone's going to be a different size. And now I'm literally going to label this. This leg next to 40 degrees, that's my adjacent. This one over here, this is opposite, and this is hypotenuse. Now that I've done that, I've done all of number 1. Now I'm going to measure their sides. Okay? This right here is in centimeters. So my length from point to point, this is 5 centimeters. This right here is 4.5 centimeters. And this is 6.5 centimeters. Okay. I have done number 2. And this is 1 through 2. There we go. Number 3. I'm going to make my adjacent leg over my hypotenuse. So for me, mine is going to be 5 over 6.5, and I'm going to stick that in my calculator and find out what I get. And I'm going to get 0.77 because I'm going to round to 2 decimal places. Then I'm going to go my opposite over my hypotenuse. So that's 4.5 over 6.5. That's going to give me 0.69. And then finally, I'm going to go and do my opposite over my adjacent. Okay? And my opposite is 4.5. My adjacent is 5. Rounding to 2 decimal points, I get 0.9. You should not have the same numbers of me. Everybody should have different numbers. Okay? And then you're going to compare. Let's make a little chart. Okay? This is going to be adjacent over hypotenuse. This is going to be opposite over hypotenuse. And this is going to be opposite over adjacent. This is going to be me, so this is Miss Murphy. And then you're just going to label everybody at your group and write down what theirs is. Everybody should have a different triangle. Okay? Number 4 is going to compare what you know about these. Okay? Mine is 0.77 for my adjacent over my hypotenuse. Opposite over hypotenuse is 0.69. And my opposite over adjacent is 0.9. So you can use mine as one if you would like. That's Miss Murphy's. And then you're going to list yours and everybody at your table. And then you're going to, number 4 is you're going to make a conjecture or compare your answers. What do you know? Opposite, adjacent over hypotenuse are all within what? Opposite over hypotenuse are opposite over adjacent. Are they the same? Are they different? Are they close? Are they close by how much? And then you're going to go ahead and do phase 2, which is draw a sketch that does not have to be to scale of what your triangle would look like if it were dilated by a factor of 3 at the vertex of 40-degree angle. Find the ratios of the adjacent leg over the hypotenuse, opposite leg over the hypotenuse, and opposite over the adjacent for your dilated triangle. So if you're dilating something by 3, you're going to times each of the sides by 3. Right? So instead of 5 centimeters, mine would be 15, right? Okay, what did I notice? Make a conjecture. Phase 3 is you're going to draw a sketch and dilate it by a factor of 1 divided by the hypotenuse. So mine, I would time each side by 1 divided by 6.5, so 0.54. Okay? Then I'd find the ratio of adjacent over hypotenuse, opposite over hypotenuse, and opposite over adjacent, and talk about what I noticed. Phase 4, if you want the ratios of adjacent leg over hypotenuse, hypotenuse leg over, opposite over hypotenuse, and opposite over adjacent, for a right triangle with acute angle of 50 degrees, could I find them without drawing a new triangle? If I can, what are the new ratios? Phase 5, we're going to draw a triangle with one acute angle of 80 degrees, and find all those things, make my conjecture. Since I know the ratios for a right triangle of 80 degrees, I know that those ratios for an acute angle of blank degrees, what are they? Okay. So you're going to do all this. It is going to take you more than one day. You should be able to get through 1 and 2 by the end of the hour today. Okay, 1 and 2. If you're having trouble with phase 1 and phase 2, let me know. I'm going to leave this up on the board, but I'm going to stop it now and let you guys work. If you're on your phones, I'm going to take them. You need to be doing these instructions, okay?